Alright, can people hear me? I think we're gonna start. Yeah, the sounds looks good. Okay, perfect. So here so let's get started. Hi everyone, I hope you're doing good. The week was productive, or at least was as satisfying as you wanted. So I wanted to continue on the HiGHS solver that we started in the last stream, and more specifically I wanted to work on a feature that was missing for some of the math opt interface tests, that was naming the constraints. So the last time we named the variables, I think, variable name, we must have something here. Yes, so we implemented variable names and tested that. What we'll do now is implement variable constraint names, which is roughly the same mechanism. So yeah. I think we will have less trouble for constraint names, because one constraint would be attached to one name and that's it. And usually, while in variables we had, for each variable you can have only one upper bound and one lower bound. And so each constraint of type one variable in a set lower or one variable in the set interval or anything, you had to map this name to something else, and so we have a huge discussion going on the pull request that we opened last time in the last stream. Right, so let's get started. So sorry about the delay, I was finishing my raviolis. Yeah, we all need to eat, I guess. And yeah, what is... So we'll start by checking what we did last time. It was a bit more than a week ago, I think, so I've already forgotten what we did. So supports variable name, okay, that's a thing, and then we do that, and then I guess we use variable name later here, so we can get the variable name of a given variable index, and then we can set it, okay, and then we can get the variable index that corresponds to a given variable name. Yes, perfect. All right. So we'll check what the documentation of, let's open math opt interface. Let's check what the documentation is saying for this. I think this stream will be rather short, because it's not going to be that much of a feature. Alright, constraint name, identifying the constraints. Okay. So what I wanted to see also is how does Cplex, another solver, handle it. So I just checked where does constraint name appear. Supports here. So I don't think this is very interesting. And here MOI constraint name. Here MOI wrapper. So this is the master branch on the Cplex wrapper, which is one of the references that's fairly up to date, let's say. Yeah, here set the constraint name. So you give a given scalar find function in name, okay. So interestingly, Cplex has a mechanism to handle constant names, but we don't in HiGHS. So HiGHS, the native solver, doesn't have that. So this means that we need to cache, let's say, the names of the constraints on our side, which means we will have sort of a dictionary. We'll start with that. Y wrapper. So this, we have a variable map. We'll add just the same thing. Constraint map. Constraint map will be dict. We can't have. We can't put all of them in the same type of map, I think. That doesn't seem very satisfying. Less than. We could map them by type of constraint. So we have either less than, greater than, and interval. Either we skip interval or we add it as a specific one. Constraint less than. Dict MOI variable index, so it would be MOI constraint index, and the constraint is parameterized by function and set. So function will be MOI dot scalar find function of type float64, and the set will be it sounds very frustrating to have this whole repetition here. Yeah, I think we don't have a choice. Less than float 64. Worst thing, we'll just have this very inelegant solution, then we'll improve it later when we see a common structure arise. Greater than, and that's here. And maybe we can skip interval. No. Constraint index, interval, float 64 string. Okay. Oh, and we also need the dictionary with the good types. Maybe I was a bit optimistic on doing a quick stream. So this, oh boy, new, that. So that's the variables. Maybe we can have a type unsafe or a type unstables way. Eric asking, how do other solvers handle this? It's an excellent question. That's initially why I had Cplex open to check. So it seems that Cplex itself natively handles names, and so the Cplex native solver handles names as strings or as characters. No, as strings, yes. But what we don't have here is a way to do that. I'm not sure how CLP, for example, would be doing this. Let's check. I think I do have package. I do have. Let's say CLP. Let's pick the first version and G. Nope, just no constraint name. It's ignored. So you can't. So you don't have constraint names at all. One thing I'm wondering if maybe it's what the MOI cache optimizer is for. Cache, no, no. my utilities, caching optimizer. So what does this one do? Yes, so caching the constraints seems like a very common thing. If you have a way to identify your constraints with a constraint index and your variables with a variable index, there should be a way to handle dictionaries in a unified way for all the solvers, which is not done here. Caching optimizer is an intermediate layer that stores the cache of a model, links it to optimizer. You suppose incremental model construction, yada yada. Okay, yeah, it doesn't say anything about names here, so it's just about incrementally building a model. So no, wrong intuition I had. So, oh no, I'm wait. For a moment, we'll go the ugly way. We'll go with constraint map, and then this will just take any type of constraint index and a string, which will be a name, and so we don't need all of these. Otherwise, this would be a nightmare. So this means this one is removed, and oh, we still need a string, yes, and that's it. Yeah, where is this one? Not aligned. Okay. Okay, so we have something now. So we're just constructing our cache, let's say our constraint map cache, with this, which is type unstable, so will be slightly slower. At the same time, I don't think indexing into the strings of indexing to look for the string that corresponds to a given constraint doesn't need to be too fast. I don't think this is a critical operation when handling optimizers. I might be wrong, but this can be optimized later. For a moment, so we have constraint index, perfect. So first thing to do is we'll constraint name. Yes, I guess the get function is the first one to get started with. So we are in MOI now. Where do I put this? We have too many things here. All right. So get on an optimizer. I call it O in HiGHS. A given constraint name with a constraint index, scalar find function, and any. Okay. And return. So in that case, it will be O dot constraint map. So in that case, we have a name, and we want the function, the constraint index that corresponds. So we have to iterate over it, I think. So this will be CI. No, we want the constraint name. No, we don't need to iterate here. Oof, that was a long week, wasn't it? Constraint map, and then we index that at C, and that's returned. And we should maybe use this with get. So if we don't find it, we return an empty string instead of just blowing things up. I think that's the convention. Right. And then set, which would be roughly the same thing. Well, not roughly the same thing here. So set for an optimizer the constraint name with the constraint index and the name. Do we verify first that the constraint index is valid? It's a good question. I'm not sure. So we return nothing at the end, that's a constant. Maybe to do should constraint now constraints index be checked, and then so for a moment we'll assume we don't need to check it, and constraint map, so it would be at C equal the name, and we return nothing. Okay, it wasn't too hard. So here for the any, yes, we assume that the constraint index is valid, and if it's valid, then it has to be one of interval less than or greater than, because otherwise we would not even be able to construct this constraint index. So it will not even exist for this optimizer. So one piece of philosophy in Julia is don't try to over constrain everything. If it blows up, it's the user responsibility to check their input and so on. So except for things that are really non-trivial, for the rest of it, it's up to the user. So if the user constructs a constraint index on a model that's not this one or stuff like that, then it's a bit their fault. They're messing up with things, and so they have to debug their problem. Although it's not always the case, but it's a good philosophy not to check everything yourself. Right, so the last thing we need is MOI that supports. So for an optimizer, we don't even need verbal here. So an optimizer MOI constraint name and MOI that I think that's just it. How was it done? Type constraint index, okay, here. Ah, right, it's we didn't do the reverse search yet. So we need another form of support with constraint name. It's not there. Curious. Well, I assume it's fine like this, we don't need it. So we did the forward search, let's say, which is the easy part, which is assign. You have the key and you look for a value, or you have a key and the value and you assign the value to the key. We want now the reverse search, which is a bit less trivial, which is given a name, give me the corresponding constraint index. So get the constraint name, and then we get a name. Just string. And then here we are passed type. Yeah, subtype of constraint index. think that's how it's done also here. Micro src. Type constraint index. Yeah, that's for the support part. Search for concert. Yeah. For constraint's name. And how it's done now. So single variable when I'm interested in that for a moment. Yes. Nope. What we want is being given a string. Yes, here. No, that's a set. Weird. I thought we would be able to do it, maybe not. So it seems it's only the forward search that seems to be implemented in simplex, meaning give it a constraint index and it provides you with the name, not the other way around. It seems. Constraint name and we provide an index. Constraint name and we provide an index. That's for set. Name index. Yes. Alright. So no reverse search. I will be sure that it's exactly the same logic as we did for variable names, and variable names was name. Yes. We didn't do it here? I thought we would. Curious. I was sure we did it. Okay, no, I just streamed it, so there's no reverse search. And in that case, so we just need the support here. That should be it. So, now that we have that, I think we can try to run the tests from MOI, which use these constraint names. So first, let's a quick sanity check, see if we don't have any missing piece of syntax or anything. In the same time, I'm going to yes, here source test, no, and unit test and linear. No. What unit test do we have? Unit tests. I think we had noted the last time. Okay, for test still pass all. We had noted the last time which things were missing, which we can check now. Test and model wrapper. Attributes, variable names, unsupported test. No. Wait, how is this unsupported? It should get row parameter is not okay. Well, it's not what we're doing now, so we're just not focus on that. No, so it might be in, is it in run test directly? No. Model empty. Variable names. Unit MIT. Okay, so we test with variable names. No, where was variable names implemented? Maybe in attributes, constraints, name. Nope. In variables, duh. Get variable. I think this one was not passing, and it should be. Our goal is to make it passing now. So what do we need to pass it? O and config. So empty that, and then MIT dot get variable, and this will take the optimizer and config. Alright, let's run the test. So this will be failing, I assume, like usual. We generally don't have luck with the first run of our test, that's normal. Well, some people do, but I usually don't. Yes, there we go. Unsupported constraint, single variable greater than. Single variable in greater than. It is definitely supported by the model. No, that's the one in map of the interface. My wrapper. Let's open a new window and check our source. Support constraints. Yes. That's what we want. Oh, I thought we had done the. Oh no, we did it in the other PR that's not yet merged. I'm a bit bothered because this other PR is not totally finished. So if we merge it into this one, it might lead to some problem. Oh, we can try. Git merge. I should not be doing this. Yeah. Oh. What did I change in total? Yeah, but I get some conflict. Add constraints map, and then git merge. Yes, that's alright. We can fix this conflict. Oh, just one test and my wrapper. Then we look for master. Oh no, yes, here. Okay, so where was the conflict starting? But that's not too bad. We can just erase that, and that's it. So let's rerun our test now. Okay, not too bad. Still one error. Set attribute not allowed. Constant name. Setting attribute cannot be performed. You may want to use a caching optimizer. we said we can now set through our fallback. Ugh, these fallback feel a bit like anti-patterns. Well, constraint name, constraint index. Okay, so set HiGHS optimizer, constraint name, constraint index, and string. We don't have this signature. This means, so if we fall back to the method that is in math of the interface and we're not using our method, this means that our method is either not defined or not specific or not more specific or even strictly less specific than this one. So we are missing some signatures in the type maybe, or we are over constraining our type. Optimizer constraint name, check. No, oh no, this is definitely Cplex. We might want to close Cplex for now. Micro source constraint name, supports constraint name, yes, and set. So optimizer constraint name, constraint index. So the constraint name for a single variable constraint is a bit tricky, because this is the one we are kind of erasing. I thought, that's okay, I get it, I get why now. This one, yes, here we only support scalar find function and not single variables. The thing is, when we add a single variable to a bound, or we add a bound to a single variable, the name attached to there is no name attached to the constraint. Yeah, I think because of that, this was the discussion I was having with the MOI and JuMP developers, that we need to cache the constraints and not to pass the bounds directly, which is a bit of a shame. This means we cannot use the full power of the solver, just pass it the bounds for variables, and we have to store it in between. Oh, and also when we get a constraint index and we don't find it. Oh no, when we try to find the index, it should return nothing. So I guess that means we are gonna need a constraint. A single variable constraint map. That's embarrassing. No, this is fine. So it means we could just relax maybe the constraint index here into just any constraint index. And the same thing here. Yeah. Maybe, so this will work. So I wanted here to relax the type of constraint indices we accept, meaning we can accept any constraint index. Ideally, we would want to constrain to be either single variable or a scalar find function. MY is valid model X. Test failed. So in variable, this one. So what should be valid here? Yeah, you know what? Let's just try it also from scratch here. HiGHS, and then const MYU equals wait, what? I thought I imported my already. Okay. No, module. Okay. And then this one. Great. And now the test is if we get this variable, nothing. Great. Now if we get this variable, yeah, we get that. So that will be x, and y that is valid. And that's what should return true. So which is called here. So we seem to default to a fallback. Let's check if Cplex is defining is valid somewhere. Yeah, definitely. Micro my wrapper 488. Yes. So we should define is valid somewhere. I didn't even know we had to. Nope. We just copy the one from Cplex. And for now, the logic will be we cannot remove variables. So any variable that's between 0 and the number of variables minus 1 is valid. Except if we have something on the Judas side that's already counting the variables. Nope. It means variable index means my that get that will be number of variables is greater or equal to so v dot index v dot value, sorry, plus 1. So if we have an index 0, so the first variable will be at index 0, it means our number of variables must be at least 1. Cool. And this works because we don't have holes in variables. No variable will be deleted from the model, so we always keep all variables for a moment. Okay, will this make the solver happy? not define. Oh, not define. Where is that? Oh yes. Rather disappointing error. That's the kind of nice thing I would appreciate, to have a really powerful language server protocol for in Julia. Having, hey, you didn't define this, are you sure you want to use that? It's already the case a bit on Visual Studio Code. I'm just not really comfortable using it. Yes, we now pass the test. So that's Cplex, that's the test. We now have this test wrapper. Oh, so we added this. Oh, yes. No. Oh, that was added. MY unit tests. So yes, test. I guess we can now try some of the MY unit test. Wait, where was it? I don't have a line number. Yeah, 166. Did I dream it somehow? Ah, here. Okay. So this is all the excluded unit tests, but at least we have some unit tests with that, and I hope this will kind of work. I think some tests are still gonna break, but not all of them, and less of them than before, and that's the good news. So some tests are not gonna pass, and either this is a feature we don't want to support yet, so we'll just exclude it from the unit test, or this is a feature we are supposed to support, and then this is a bug and we have to fix it. Let's support it. Constraints, scalar find function, greater than. I thought I merged that. Yes, I do support the constraints. Oh wait, no, it's for scalar find function. That's for getting constraint set. Yeah, I guess we're gonna need a kind of constraint map here again, which will map so each time we add a row, it gives us a number, a row number, and so on the MOI side, we need to collect these row numbers with their given type, so which is scalar find function in a given type of set, which will be either less than, greater than, and less than, greater than, interval, sorry. And yeah, that we haven't done. I'm not sure I'm gonna do it now. I try to keep it in a reasonable length. Yeah, but I guess we can do that. So yeah, that we definitely need to do. So it's a good thing the test failed here. This one is exactly the same thing. The surprising thing is there is no bridge for when you only support scalar affine function. When you only support when you only support scalar affine function in interval, the surprising thing is that there is no bridge giving you scalar affine function in greater than and smaller than. Alright. So I think we can add the same thing as here, but for less than, and this will just fall back to the one above with infinity, because this is basically what HiGHS is doing. And so this will be here. So we basically call this one interval set equal y.interval, and the interval will be, so with lower and upper, so less than has an upper, so the lower will be minus inf, upper will be set.upper, and then we add the constraints with optimizer, same function, and interval set. And this gives us interval CI, and from this CI we construct the same constraint index, but with our interval CI dot value. So we take the same value and we use it to construct the real constraint index, which is constraint less than constraint index. So, and we'll add y less than, and now the same thing for greater than. Oops, what do I do? Greater than true. And now this is set lower and inf. And this doesn't change, perfect. Okay, this was very quick. So let's see if it works. So we had 19 tests erroring, so we'll see if it's now better or not. We still have some tests erroring, but now we can hope that some of the ones that were erroring and that we didn't want to error will be removed, and we'll be left with some tests erroring that we are fine with, like some features we don't support or that are natively not supported by the solver. What is that? Single variable greater than But we do support these. Supports constraints. Oh no, this is simplex. Supports constraint. Yes. This one. Is that a breach problem or a proper problem from outside? Solve singular variable. So that's in this unit test here. Where's this one saying? Variables x, okay. I don't see what the problem is here. Let's try to just add this constraint, for example. I think I need a new HiGHS session for HiGHS. Right, so O is optimizer, add variable, O, and this will be X, and then add constraints to O, which is X greater than, let's say, 0. Yeah, it works. Then I don't see where was this test coming from, and we still have 19 errors, so that's really not great. Vectorifying function non-positive. See, this is definitely not supported, and this should be bridge. I don't see how this is not the case. Okay, this is now also supported. Let's try it ourselves. Yeah, we need add variable variables. Let's say we call that v. 2. Okay, and then let's say add constraints. Okay, sounds right. Yes, this doesn't work here. So we can now add less than constraints and a greater than, I'm sure. Yeah, both seem to work. One problem here is the constraint index seems to be the same, which should not happen. I think the index should increase. Get constraints, and this has to be typed with my scalar affine function float 64 and this is that in less than float 64. I forgot something. Yes. Modeling of type HiGHS optimizer is about accessing number of constraints. Oh, to do. Oh wait. Alright, we do have this one, but only for. So yeah, that's where we need to cache exactly if we added an interval or six. Oh, so that's weird. How come we only got a constraint index of 1 every time here? If I add it again, seven. Okay, so why is my constraint index always not increasing? Yeah, this will be a bit more careful investigation on why this is happening. The attributes. Why are we returning this? Why are we getting this one? If we add constraints, interval we always get the same constraint index. 120 here. Oh, yeah, good catch. This is not a row index here. This is a boolean saying was this added or not. So this is okay, which we'll not check yet. And row index will be num rows my.get. So that's great because we could find a bug here with what we did. So yeah, the trick is add row is not returning the row number, but the boolean saying was this correctly added or not. But again, we're working with a C wrapper over a C++ project. So when you go through the C wrapper, you end up not having a boolean type because C, and then you end up with integers all over, or pointers to floats, and you don't know what it corresponds to. Very weak semantic, but yeah, we're not here to gripe about C. So number of rows would be get number constraints, but we could get it directly, I think. So my.scalar affine function float 64 interval 64. Yes, so that's the number of rows. And we want this number of row minus 1. Oops. To keep 0 indexing. Yeah. Okay. This will, I guess, reduce, maybe not reduce the number of failed unit tests, but at least reduce the number of bugs we have around. Here it comes. So what is not working? Scalafine function greater than. Constraint not supported by model. What was this one again? Yeah, this one we didn't know, because it is supported by the model now. Still 19 errors, huh? And these I still don't know, but I think these are consequences of the ones not working before. So we'll concentrate here. Alright, I think my time is soon up for today, so at least we fixed a bug. That's great news, I guess. I'll do the rest of it in another stream or later, but at least we have a beginning of improvement. I stop the stream now. If you have questions, don't hesitate to reach out or anything. Yep, and take care.